Hello viewers, in the first part of this chapter, I have explained what is a chemical reaction and how to balance a chemical reaction. And in this part, I am going to discuss about types of chemical reactions. Now, chemical reactions are of basically 5 types. First is called combination reaction, second one decomposition reaction, third one displacement reaction, fourth one double displacement reaction, and the last one which is called oxidation-reduction reaction, and commonly it is called redox reaction. So these are the 5 different types of reaction. So first let me discuss about combination reactions. Now what is a combination reaction? When two elements or compounds react chemically to form a single new compound, then the chemical reaction that takes place is called a chemical combination reaction. It is also called chemical composition reaction. A combination reaction is generally represented as A plus B gives AB, where A and B are elements or compounds and AB is the newly formed compound. So in combination reaction, in the first case it is a combination of two elements to form a compound. In second case, it is the combination of an element with a compound to form a compound, and in the third case, one compound reacts with another compound to form a new compound. Let me give one example of each now. Here, hydrogen is an element, oxygen is also an element. These two elements are reacting to form a compound which is H2O. In case of hydrogen, here 2 atoms of hydrogen, here also 2 atoms of hydrogen, but here 2 atoms of oxygen and 1 atom of oxygen. So if you balance, you have to write 2 here and 2 here. Then it will be 4 atoms of hydrogen, 4 atoms of hydrogen, 2 atoms of oxygen, 2 atoms of oxygen. So this type of reaction where one element combines with another element and it forms a compound, this is a type of combination reaction. Now in the second case, an element is reacting with a compound, or you can say one compound is reacting with one element and they are forming a compound. Say sulfur dioxide, it is not an element, it is a compound. This compound is reacting with element oxygen and as a result it is forming sulfur trioxide. So this type of reaction also is an example of combination reaction because one compound is reacting with one element and they are forming single compound. Though this reaction is not balanced, if you want to balance, you have to place 2 here and here 2. Now we can see here 2 sulfur, here 2 sulfur, oxygen 2 2 ja 4, 4 plus 2 6, and here 3 2 ja 6. That means both sulfur and oxygen atoms are same in both the cases. So this is the example where one element is reacting with a compound to form another compound. Now in the third case, when one compound reacts with another compound to form a new compound, then it is also a combination reaction. So we can consider the example like suppose carbon dioxide reacts with water and it forms carbonic acid. Formula of carbonic acid is H2CO3, and during the reaction small amount of heat is liberated, which is represented by this triangle sign. So I have given you 3 different examples where in the first case element reacted with one element to form one compound. In the second case one element reacted with one compound to give a new compound. In the third case one compound reacts with second compound to give a new compound. So these are the 3 cases which we have to consider in case of combination reaction. Let me now discuss decomposition reaction. Second type of reaction is called decomposition reaction or decombination reaction. Now in case of decomposition reaction, we can say the reaction in which a compound breaks down to form 2 or more simpler substances on heating or absorbing some kind of energy is called chemical decomposition reaction or a chemical decombination reaction. Suppose we are having a chemical AB. This chemical, which is a compound which on heating or by passing electricity or by light, if it breaks to form A and B, and this A and B could be elements or compounds, then this type of reaction is called decomposition reaction. Clearly, a decomposition reaction is the reverse of combination reaction. In case of chemical combination reaction, 2 elements or compound combined to give a single compound, and here one compound will break to give 2 or more element or compounds. Now, decomposition reactions are further classified into three types. The first type of decomposition reaction is called thermal decomposition reaction. Thermal means heat. That means when a compound is broken down into smaller components by the application of heat, then that type of decomposition reaction is called thermal decomposition reaction. Now, say for instance, if we take magnesium carbonate MgCO3, this magnesium carbonate, if it is heated at 1000 degrees centigrade, okay, if we take magnesium carbonate and if we heat it strongly at a temperature of 1000 degrees centigrade, then it is going to form magnesium oxide MgO plus carbon dioxide. Carbon dioxide being a gas, it will escape from the system. So here magnesium carbonate will decompose to form magnesium oxide and carbon dioxide. Since we have broken magnesium carbonate by heating, that's why this type of reaction is called thermal decomposition reaction. Now, second type of decomposition reaction is called electro-decomposition reaction. In case of electro-decomposition reaction, a compound in aqueous solution means solution in water or in the molten state, is decomposed by the passage of electricity, then that is called electrolytic decomposition or simply electrolysis. Now, if you take water and if you add few drops of sulfuric acid and if we pass current, electric current, then this water will decompose in the form of hydrogen gas and oxygen gas. So here, by using electricity, we are decomposing water to hydrogen and oxygen. So this type of reaction is called electro-decomposition reaction. And remember students, in case of electro-decomposition reaction, the compound which is to be decomposed must be in the aqueous solution or it must be in the molten state. Otherwise, this reaction will not proceed. Third type of decomposition reaction is called photochemical decomposition reaction. In case of photochemical decomposition reaction, a compound is decomposed by light so as to form two or more substances, then it is called photochemical decomposition reaction or simply photolysis. Now, if you take hydrogen peroxide, H2O2, this is the formula of hydrogen peroxide, and if we use light, then this hydrogen peroxide will split in the form of hydrogen gas and oxygen gas. Since this decomposition has taken place in the presence of light, so this is called photochemical decomposition reaction. It is often seen that in case of medicine, some medicines are kept in dark color bottles. Now, why they are kept in dark color bottles, I think you can understand now, just to stop this photochemical decomposition reaction. Because if light strikes those chemicals inside the medicine bottle, then the chemicals may convert to something else. Just to keep the medicine in its proper condition, they are kept in dark colored bottles. So I hope combination and decomposition reaction, these two reactions are now clear. Let me discuss now displacement reaction. Now, what is a displacement reaction? When a more active element displaces a less active element from its aqueous ionic compound, the reaction that takes place is called a chemical displacement reaction. Now, as you can see, here AB is reacting with C and it is forming CB plus A. Here AB is a compound of less active element A. C is more active than A. So C is going to displace A from AB. As a result, after the reaction, it will form CB and A will be displaced. To understand displacement reactions properly, we have to understand activity series. The arrangement of elements in the decreasing order of their electropositive character is called activity series of metals. Now, all the metals no need to consider, we can use the commonly used metals. Now, let me discuss the activity series of commonly used metals. Here I have written potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold and platinum. Now, to remember these metals, it is very difficult to remember like this. Just remember one line. Popular scientists can make a Jew in low humid countries more satisfactorily and peacefully. In popular, it starts with P and here it is potassium. Scientist S, sodium. Can calcium, make magnesium, A aluminium, Ju zinc, In iron, low lead, humid hydrogen, countries copper, more mercury, satisfactorily silver Ag, and oram, oram means gold, and peacefully platinum. Though platinum is not commonly used, so sometime in some books they write up to gold. So you can see in this list potassium is the most reactive and gold is the least reactive. Now let me discuss few examples. Suppose when copper sulfate, it is CuSO4, copper sulfate, when reacts with iron, it is going to form iron sulfate and copper. Now here if you compare this copper and iron in the activity series, you can see this is the position of copper and this is the position of iron. So iron is more reactive as compared to copper. Since iron is more reactive, it is going to displace copper from copper sulfate solution. So here this iron is going to displace copper from its solution, and instead of copper it will be iron. So we got iron sulfate and this copper will be displaced. Similarly, if you take another reaction, suppose zinc plus sulfuric acid is H2SO4. Now here out of zinc and hydrogen, just see position of zinc is this one and hydrogen is this one. So zinc is more reactive as compared to hydrogen. So zinc is going to displace hydrogen from its solution. So this hydrogen will be displaced. So we are going to get zinc sulfate plus hydrogen gas. Clear? So these two are examples of displacement reaction. If you consider copper sulfate and zinc, now out of copper and zinc, which is more reactive? This is zinc, this is copper. So zinc is more reactive than copper. So zinc is going to displace copper from its solution. So as a result, we are going to get zinc sulfate plus copper. Now if we react zinc sulfate with copper, then what will happen? Out of zinc and copper, zinc is more reactive. So it is not possible for copper to displace zinc from its solution. So there will be no reaction. Here you write no reaction. There will not be any reaction because copper is less reactive. Copper is less reactive than zinc. So copper cannot displace zinc from its solution. Now next one is double displacement reaction. What is a double displacement reaction? A chemical reaction in which two ionic compounds in their aqueous solutions react by exchanging their ions or radicals to form two new compounds is called a chemical double displacement reaction. Suppose AB is reacting with CD, and suppose this is positive ion, negative ion, this is positive, this is negative part. Then after the reaction, what will happen? This positive and this negative, they will form AD, and this negative and this positive, it will form CD. This type of reaction is called double displacement reaction. Now this double displacement reaction can be classified into two kinds. First one is called precipitation reaction and second one is called neutralization reaction. Now in case of precipitation reaction, when the aqueous solution of two ionic compounds react by exchanging their ions or radicals to form two or more new compounds such that one of the products formed is an insoluble salt and hence forms a precipitate, the double displacement reaction is said to be a precipitation reaction. Clear? That means after the reaction, one of the product will be insoluble salt and as a result it will form a precipitate, then only it is termed as precipitation reaction. Let me give one example now. Suppose sodium sulfate, we can write Na2SO4. When sodium sulfate reacts with barium chloride BaCl2, then it is going to form NaCl plus barium sulfate. And remember, these are in the aqueous state. Now sodium sulfate, we can think like this. It will form ions like Na plus and SO4 minus 2. Here it will be Ba plus 2 and Cl minus 1. Now this Na plus, it has more affinity for chlorine than sulfate. So sodium will react with chlorine and it will form NaCl. This barium has more affinity for sulfate. So barium will react with sulfate to form barium sulfate. This type of reaction is called double displacement reaction. It is also known as partner exchange reaction. I hope this example is clear. Here sodium sulfate can be considered as sodium ion and sulfate ion. Barium chloride can be considered as barium and chloride ion. Here sodium ion and chloride ion will react to form NaCl and barium ion will react with sulfate to form barium sulfate. Now in this reaction, this barium sulfate, it is insoluble. Since this is insoluble, so it will be the precipitate. We can give this down arrow here. Now after this reaction, it is found that a white precipitate is formed, and this white precipitate is because of barium sulfate. Just because one precipitate is formed after the reaction, that's why this type of double displacement reaction is known as precipitation reaction. Let me give you another example. Now when sodium hydroxide reacts with copper sulfate, both of them in the aqueous state, when these two react, then it forms sodium sulfate and copper hydroxide. Here sodium hydroxide can be considered as Na plus OH minus. Copper sulfate can be considered as Cu plus 2 and SO4 minus 2. Here sodium will react with sulfate to form sodium sulfate. Copper will react with hydroxide ion. As a result, copper hydroxide is formed. Now this one is bluish in color because we know copper sulfate is blue in color. After the reaction, a bluish white precipitate will be formed, and this is because of the copper hydroxide. So we have to give arrow. So in this reaction, this is the precipitate. So this is another example of precipitation reaction. Let me now discuss neutralization reaction. In case of neutralization reaction, we can say when an aqueous solution of an acid reacts with a base by exchanging their ions or radicals to form salt and water as the only products, the reaction that takes place is called a neutralization reaction. Okay, so in case of neutralization reaction, one acid will react with one base, and after the reaction, it is going to form salt plus water as the only product. This type of reactions are called neutralization reaction. Say for instance, if we take sulfuric acid, formula is H2SO4. When sulfuric acid reacts with sodium hydroxide, which is a very strong base, so this one is acid, this one is base. After the reaction, it is going to form sodium sulfate Na2SO4 plus water. This sulfuric acid, we can consider it is H plus and SO4 minus 2. Sodium hydroxide, we can consider Na plus and OH minus. So this sodium and sulfate, these two will react to form sodium sulfate, and hydrogen and hydroxide, these two will react to form water. Now in this reaction, it is not balanced because here it is sodium 2, here it is sodium 1. So we have to place 2 here. Here hydrogen will be 2 plus 2, 4. So here also it must be 2. Now it is a balanced equation. So this type of reaction where an acid reacts with a base to form salt and water, this type of reactions are called neutralization reaction. Let me give you another example now. Suppose hydrochloric acid, formula is HCl, is reacting with magnesium hydroxide. So it will be MgOH2. Then it is going to form magnesium chloride plus H2O. Remember that it must be in the aqueous state. Now this hydrochloric acid can be considered as H plus and Cl minus. Magnesium hydroxide can be considered as Mg plus 2 and OH minus 1. I hope these cations and anions are clear as we have done in class 9. Here magnesium will react with this chloride ion. As a result, it will form magnesium chloride. Here hydrogen will react with hydroxyl ion to form water. So here also an acid is reacting with a base to form salt and water. So this is also an example of neutralization reaction. I hope double displacement reaction is now clear, and in this double displacement reaction we have to remember both precipitation reaction and neutralization reaction. I hope combination reactions, decomposition reactions displacement reactions and double displacement reactions. These four are now clear. In my next video I am going to explain oxidation and reduction reactions and corrosion of metals. That will be the last part from this chapter. Okay, thank you for watching. Take care.